Last time we met, we were talking about how to write numbers into scientific notation. And we discussed the fact that the whole purpose of scientific notation is to write like an abbreviation of an extremely large or extremely small number. But the honest truth is, if the only purpose of scientific notation was to just make the number smaller to write, okay, instead of very large or very small numbers, then I think someone would have told them, get over yourself and just write it the way it's supposed to be. But the honest truth is, the reason that scientific notation was invented was not to write numbers in scientific notation, but to work with numbers in scientific notation. Extremely large and extremely small numbers. For example, if you were an astronomer, you might work with a number like 93 million, which is the number of miles from the Earth to the sun, approximately. Okay, and you might work with 186,000, which is the number of miles per second that light travels. And for some reason, maybe you would have to multiply these times each other. And without scientific notation, you'd have to like multiply 93 million times 186,000 by going 0 times 0 is 0. Hopefully you would not do that. Hopefully you just bring these 3 zeros down. I don't know why I was starting to multiply by them. I got a lot of people in 7th grade who think that's easier. But it's easier just say 0 times this whole thing and bring it down. We've discussed that since 5th grade. Hopefully you've learned that. Anyway, even if you just bring these 3 zeros down, 6 times 0 is 0, 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 6 times 3 is 18, carry you 1, 6 times 9 is 54, and 1 is 55. Put zeros under these so that when you multiply by the 8, the answer starts on the 8. 8 times 0 is 0, 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 8 times 3 is 24, carry your 2. 8 times 9 is 72, and 2 is 74. Put these zeros here so that when you multiply by 1, the answer starts under the 1. 1 times 0 is 0, 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 1 times 3 is 3, and 1 times 9 is 9. So when I add, this is 0, 0, 0, 0, 0, 0, 0, 0, 0, 8, 5 and 4 is 9, 5 and 4 is 9, plus 3 is 12, carry you 1, 1 plus 7 is 8, plus 9 is 17. And when you put your commas where they belong, put the decimal in the the comma in the wrong place every 3 places. When you put the commas where they belong, your answer is 17,298,000,000,000. And you go, Mr. Dew, no astronomer would deal with that. They would just use their calculator. I don't think so. Because first of all, a calculator screen can only fit 7 or 8 numbers in it. And even if you had a good one that fit 8 places in it, like 93 million, you couldn't fit this answer in there. Matter of fact, your answer would come out to be something funky looking like this, 1.7298 E13. That's how the calculators usually do it that I have. And again, you might not understand what that means. All right, so in scientific notation, instead of doing it this way with all the 0, 0, 0, which would be very, very easy to make a mistake by 1 0, and you might think, well, 1 0 off won't make a big difference. It would make a gigantic difference. 1 2 less zeros makes 17 trillion, 1 trillion. 1 too many zeros makes it 172 trillion instead of 17 trillion. So you're talking about being trillions and trillions off just by 1 0. Could you see someone at NASA say to an astronaut out in space, oh, I'm sorry, but we made a mistake and added two little zeros, so we didn't account for enough fuel to come back. Good luck. So again, you have to have a way to do this where you won't make a careless mistake with all the zeros. And that way is scientific notation. So the first thing you have to do to work a problem in scientific notation is write the problem in scientific notation. And remember the steps for that. Number one, put the decimal behind the first natural number. Number two, drop the zeros, and you come up with 9 3/10. Number three, count how many places between where you put it and where it was, 3, 6, 7, and multiply by that power of 10. Because for every power of 10 you multiply by, you move one place to the right. Same thing here, put the decimal behind the first natural number, drop the zeros, and you get 1 8600ths. And then count how many places from here to there, 1, 2, 3, 4, 5. So it'd be times 10 to the 5th. Now again, we did this to make this easier. But most people would look at this problem and look at this problem, and if you surveyed them which one they'd rather do, most people would choose this one. Because even though it's got all those zeros, at least it's something you feel like you could do. People look at this and they freak out because it looks so hard. Matter of fact, one year I had a student's mother who sent me a note saying, this scientific notation stuff is more like science fiction, okay? But the honest truth is it might look hard, but this is way easier than this is. It's way easier than this is if you know a couple of things. First of all, if you know the commutative and associative properties of multiplication. And you say, what? I heard of that. I hope so. The commutative property of multiplication says if you have all multiplying, you can change the order. The associative property of multiplication says if I have all multiplying, I can change the grouping. So if you want to work this in scientific notation, instead of grouping 9 3/10 times 10 to the 7th, change the order in the grouping and multiply 9 3/10 times 1 8600ths. Because you can multiply decimals times decimals. In the same way, instead of multiplying 10 to the 7th times 9 3/10, which would just give you this again, multiply 10 to the 7th times 10 to the 5th. Now, again, this is not difficult. Everybody in here should be able to multiply 9 3/10 times 1 8600ths. 18 carry you 1, 24 and 1 is 25, carry you 2, 3 and 2 is 5. Put a 0 here, 9 times 6 is 54, carry you 5. 9 times 72 and 5 is 77, carry you 7. 9 times 1 is, 9 plus 7 is 16. Add 8, 9, 12, carry you 1, 7, 1. Count 1, 2, 3 places beyond the decimal in the problem, 1, 2, 3 places beyond the decimal in the answer, and your answer comes out to be 17 and 298 thousandths. Now you say, that was easy, this is hard. No, this is actually pretty darn easy too. If you know that 10 to the 7th means 10 times 10 times 10 times 10 times 10 times 10 times 10. How many tens? 7. And that would be times 10 to the 5th is 10 times 10 times 10 times 10 times 10. How many tens? 5. That's what this means. So I have 7 tens times 5 tens. So what power of 10 would that be? What would 10 times 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 10 be? It would be 10 to the 12th power. By the way, what's the easy way to do that where you can skip this whole step and go straight from here to there? When you multiply with the same base number, you add exponents. We learned that already. So 7 plus 5 is 12. Now, this is my answer, but it's wrong. Why is it wrong? Because it's not in scientific notation. How do I put it in scientific notation? Well, first of all, why is it not in scientific notation? Because the decimal's in the wrong place. In scientific notation, the decimal has to be behind the first natural number, not the second. So the first thing I have to do is move my decimal one extra place to the left. And instead of 17 and 298 thousandths, I get 1 and 7,298 10,000ths. But if I move the decimal one extra place to the left, that means in my final answer, I got to move it one extra place to the right. So since this was 10 to the 13th power, which meant move 12 places to the right, since I have to move one extra place here, I got to multiply by 10 to the 13th power and move 13 places to the right. By the way, an easy way to remember to make this number larger is if you made this smaller and 17 became 1, so I did make this smaller, then you make the exponent larger. By the way, if you make this larger, then you make the exponent smaller. Anyway, most people can write these numbers in scientific notation pretty easily. I hope you can. Most people can understand and regroup the decimal times the decimal power 10 by the power of 10. I hope you can. Most people can even multiply this correctly and know the shortcut to multiply this correctly. So most people can get to this point correct. Most people get it wrong, do not do the last step and put it in scientific notation. So don't forget to go back and move it into scientific notation. And again, going back to what I told you when we multiplied these with all the 0, 0, 0, the answer was actually 17,298,000,000,000. And guess what would happen if you moved this decimal 13 places right? You would get this exact same number. By the way, I also told you in your calculator, it might give you something like this. And that looks weird, but what that's really saying is 1 in 7,289 10,000ths with 10 to the exponent of 13. So what this is saying is the same thing this says. By the way, I think we did this problem right before we had the break, unexpected break because of coronavirus, all right? And I think, if I'm not mistaken, someone told me on their calculator, it actually had 1 in 7,298 times 10 to the 13th power. So I guess more advanced calculators do it. But whether they write it like this or whether they write like this on the calculator, what they're doing is what we did here. And if the calculator is smart enough to do it in scientific notation, then you're smart enough that you could do it in scientific notation. By the way, you're going to have to know this in high school in algebra class, but you're going to more importantly have to know this in high school in chemistry and physics classes, because those are the ones that you deal with extremely large or extremely small numbers. So again, excuse me, that's how to multiply in scientific notation.